In this video, we'll be talking about data visualization and its role in data science. So by the end of this video, you should be able to define data visualization and begin to understand its important role in the data science process. Now that we're facing the explosion of data that Ilkay talked about in week 1, what matters are the skills associated with handling all of this data. Let me just read you this quote from Google's chief economist back in 2008. The ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it. That's going to be a hugely important skill in the next decade. Because now we really do have essentially free and ubiquitous data. First, I like this quote because it points out, well before big data and data science became buzzwords, the need for data scientists. In his full interview, he makes a clear case for statisticians as well. As you know, statistics is one of the core areas of data science, and using statistics is one way to try to understand data. I can't understate how important statistics is, but you'll be learning more about statistics in the next course. So back to his quote, the other part of understanding data is visualization. In fact, visualization is part of much of the process that he describes. Processing data and extracting value from it or understanding it often requires visualizing it to gain that kind of insight. And when you want to communicate your results, you'll often want to use data visualization to do that too. So visualization is central to the skills that he describes. There are two definitions of visualization that I particularly appreciate. The first, the use of computer-supported interactive visual representations of abstract data to amplify cognition. And the second, the representation and presentation of data to facilitate understanding. Both discuss the importance of representing and presenting data. Each of these is central to data visualization. But what I like the most about these two quotes is actually that they end on the same key part of data visualization: improving how we understand and think about the data. If we think about it, a pretty large chunk of our brain is dedicated to vision, and we've got some really powerful processing associated with that vision in our heads. In contrast, we're not very good at deciphering raw data. If you give me 100 raw XY coordinates, it could take me hours working with them by hand to see what they mean. But if you give me a plot with 1,000 points on a trend line, I can often tell you in seconds what the data is telling us. That's the power of data visualization. In fact, let's do a couple of quick experiments. All these data points are from one data set. Can you see the relationship between X and Y? Take a few seconds. Here's some stats about X and Y. Do they help? Not really. Correlation might help a bit, as 0.88 implies these two values are correlated, specifically that they may have a linear relationship. But we've done a lot of work, and we still don't completely understand what's going on here. But now we do. It looks like there's exponential growth for Y with respect to X, from the start at 0 until it hits around X is 7. At that point, it hits some ceiling where Y is 33, and increasing X no longer increases Y. Notice that correlation was actually a touch misleading, as it implied a linear relationship when the data on appearance doesn't imply that. But the key point is that the human visual cortex is really talented. Let's do this one more time. Here's a new set of data. All these points are from one data set. If you focus on these for a while, you might begin to notice that the X and the Y values seem pretty similar with some noise. But again, let's see if we can understand it better in a graph. Aha! The scatter plot shows us that these are really correlated. Higher X values imply higher Y, and vice versa. In fact, correlation as a statistic would have been helpful here, and would have given us the value 0.5. But the value is lower than you might expect because of the outlier. And visually, you probably notice that there's a strange outlier right here. But I don't know what to do with that information right now. With just the raw data points, I don't know if this is an error in the data or what caused that outlier. I'd like to dive into that value more, but I'm stuck without context. And that's the other point I want to make here. Without a context, we don't know what to think about the data or this outlier. In fact, without context, I'm not sure if I even care about these data. So we need context. So it turns out that these are pseudo-hypothetical midterm and final exam scores for each student in a class. Now that we know that, we can recognize that performance on the midterm is pretty closely tied to performance on the final. For instructors, this information might lead them to try to intervene for students who perform poorly on the midterm. And for the outlier, context helps as well. What happened with this student? You could figure out which student supplied this data point, and let's say after looking into that student, you find out that they didn't take the final. What it turns out then is that when you were cleaning your data, the missing entry for this student was made to be a 0. But a 0 on the exam and not taking the exam are two different things. If you remove the outlier due to missing data, you gain a better understanding of the data. And, by the way, the correlation would now be 0.89 without that outlier. Thinking more about the outlier, if we consider the correlation for the other students, we could infer that if this student were to take the final, they would have likely done quite well. But we'll get more into predictions in a later week. I also want to point out that not taking a final exam is odd for a strong performing student. So if I were their instructor, this data would cause me to inquire about their well-being. And I'd actually do that for any student missing a final exam. So these results tell me what I might be able to predict for an outcome and to take action regarding that outlier. The key point is that visualization of data means nothing without the context of the data. When we didn't know what X and Y were, we didn't really care about the data. Context is what makes us value the visualization and gives us the ability to dig deeper into the data, looking to explain outliers, and also to be able to come to conclusions about the data itself. Now that we have these working definitions of data visualization, let's talk about the ways that we use visualization to conduct data science.